So, you know how we've all been getting used to AI that can answer our questions or whip up an image? Well, that technology is already making a massive leap. It's evolving from a passive tool that just waits for our commands to an active, autonomous partner that can actually go out and get things done on its own. Welcome to the era of agentic AI.
And this quote from Google's research? It absolutely nails it. See, language models gave AI this incredible power to reason and understand. But agents give that reasoning the power to act. It's the next logical step, turning this incredibly powerful brain into something that's genuinely useful, something that can get stuff done in the real world.
Okay, so here's the real key, right? It's this massive shift from just predicting stuff to actually doing stuff. On the left, that's the AI most of us know. It answers one question, it generates one piece of text, and then it just sits there, waiting for the next command. But on the right, that's agentic AI. It's autonomous. You give it a high-level goal, and it figures out all the steps needed to get there all by itself.
So to really get a handle on how these things work, we've got to pop the hood. Every single AI agent, doesn't matter how simple or complex, is really built from three core parts. The easiest way to think about it is like a body. You need a brain, you need hands, and you need a nervous system to connect it all together.
First up, you've got the model, and you can just think of this as the agent's brain. This is that large language model sitting at the very core. It's the part that does all the thinking. It looks at the goal, it processes information, it weighs all the different options, and then it decides, okay, this is the plan.
But, a brain on its own can't do much, right? It needs a way to actually interact with the world. And that's where tools come in. These are the agent's hands. Think of them as APIs, little bits of code, connections to databases, anything that lets the agent actually do something, whether it's sending an email, searching the web, or updating a record in a system.
And finally, the magic piece that connects that brain to those hands, that's the orchestration layer. This is the nervous system. It's the process that runs the whole show. It manages the agent's memory so it doesn't forget what it's doing. It breaks down those big, complex goals into smaller, manageable steps, and it decides, okay, now's the time to think, and now's the time to use a tool. It's basically the conductor of this entire operation.
Okay, so here's the thing. Not all agents are created equal, not even close. We can actually think about their capabilities like a ladder, where each rung up represents a huge leap in how smart and autonomous they are. So let's start at the very bottom and work our way up.
So our journey up this ladder starts at the ground floor with the basic reasoning system. Then we'll connect it to the real world, and after that, we'll give it the power to think strategically, multiple steps ahead.
So, level 0. Honestly, you can't even really call it an agent yet. It's what we call the brain in a jar. This is just a pure language model. It's incredibly smart, knows a ton about all the stuff it was trained on, but it is completely, totally cut off from the real, live world.
And this example just illustrates that limitation perfectly. A level 0 model can give you an amazing, detailed history of the New York Yankees. But ask it about the score from last night's game? No chance. That game happened after it was trained. For all it knows, that game simply doesn't exist.
Okay, let's climb up to level 1, because this is where we fix that whole brain in a jar problem. At this level, the agent finally gets connected to the outside world. Using those tools we talked about, it finally gets its hands.
Just by plugging it into a simple tool, like a search API, bam, suddenly the agent can tap into live data. It recognizes that last night's game is a real-time question, it knows to use its search tool to go find the score, and then it comes back and gives you the answer. It's a simple step, but it's a profound one.
All right, now level 2, this is where things get really interesting. This is the strategic problem solver. It's not just reacting to a single, simple question anymore. Now it can understand a complex, multi-part goal and actually create a step-by-step strategy to get it done.
So for example, say you ask it to find a coffee shop halfway between two different addresses. It doesn't just blindly search for coffee shops. It actually thinks, okay, step 1, I need to use a map tool to figure out the exact halfway point. Step 2, then, and only then, I'll use a search tool to find coffee shops right at that specific location. It's that ability to plan and carry context across multiple steps that really defines level 2.
All right, now we're getting to the really cool stuff, the more advanced levels where you can see the future of this technology taking shape. And the big idea here shifts away from a single, lone wolf agent to a collaborative team of specialists.
See, at level 3, the whole game changes.
We stop trying to build one single know-it-all, do-it-all super agent. It's way more effective to build a system of specialized agents that can work together. A lot like how a human company is structured, really. The power here comes from that division of labor.
So picture this. You have a project manager agent, and its mission is to launch our new headphones. But it doesn't try to do everything itself. No way. Just like a real manager, it delegates. It hands off a task to the market research agent to check out competitors. It tells the marketing agent to draft a press release. And it gets the web dev agent to build a new product page. Each specialist does its job, and the manager coordinates the whole effort.
And then, at the very top, the absolute frontier, you have level 4, the self-evolving system. This is where an entire agent system can look at itself, identify gaps in its own capabilities, and then, get this, autonomously create brand new tools or even new specialist agents to fill those gaps. It's like having a team that can literally hire its own new members on the fly.
So these capabilities are obviously incredible, but they also bring a ton of new complexity, right? So how do we actually take these powerful autonomous systems from being just a cool prototype running on a laptop to a reliable, industrial-strength service that a business can actually depend on?
And that, of course, leads us to the million-dollar question. I mean, if these agents are autonomous, how in the world can we trust them to act safely and responsibly? Especially when they might have access to sensitive company data or, the ability to spend real money.
Well, the answer seems to be a kind of hybrid approach. On one side, you have what you could call hard rules. These are simple, predictable limits like never, ever approve a purchase over $100 without a human looking at it. But on the other side, you also have smarter defenses, basically using another AI to act as a security guard, one that examines the agent's plan before it acts, to flag anything that just looks weird or suspicious.
And all of this means we need a totally new way of managing these things, a discipline people are starting to call agent ops. You can't test these agents like normal software because they're not predictable. Instead, you have to measure things like success rates, use other AI models to act as a judge on the quality of their work, and dig through detailed logs of their thought process just to figure out what went wrong.
So, okay, when you put it all together, the brain, the hands, the nervous system, this whole ladder of capabilities, a really clear picture starts to emerge. This technology isn't just a small upgrade to the software we use today. It's something fundamentally different.
Which leads us with this one big thought to chew on. This whole shift to agentic AI forces us to ask a really fundamental question. Are we just building the next generation of smarter tools? Or are we actually truly building our future autonomous teammates? The answer to that is probably going to define how we all work, create, and solve problems for decades to come.